I'm alive. Hello, Twitch. Are we there? Sound check. We are. Oh, lovely. Clean up screen. That'll do. Okay. What are we doing today? Oh, what are we doing today? All right, we're entering into the main program, or the control unit for our main program. That'll be easy enough. Not. If it'll load up the right one this time. Okay, we're in development. The only difference is I made change in main. Yeah, that's fine then. No changes. We're okay. Nothing to explain there. Good. All right, main. Okay. How to start this. The main program loop. Most programs will have a main loop. It's not needed. But, yeah. Hold on. Let's talk about this first. So this is where we're going to start today. We've already got a loop. Qt gave us one. And it's running that application there. An interrupt application. And it has to run that so that we can access the mouse and keyboard for our graphical user interface. So I can't just do what I would normally do, which is just put a loop in, a never-ending loop for the program to run until we say exit, because that's already been done for us. But it's an interrupt loop. Well, we can use that to make our own loop. And to make it even easier, they've even given us a file in which we can do it called dev window. So that's where I'm going to put my main loop. I'm actually going to put it in the window class, which is completely wrong. It should be done separately. I don't see why. But hey ho. Such is the way. So I am going to make two new functions. One is public, and one can be private, I suppose. Yeah, I suppose it can. So we are going to have private after all down here because I always keep it separate from the variables. The public is going to be, what do we call it? my naming conventions say that it should start with dev window. So dev window, then I use an underscore. This is my naming conventions, the way I do things. It's so confined things easier. Start main loop. Yeah, do that. And we'll make it a void. Doesn't have to do it. It doesn't have to return any value. So that's fine. And in private, again, doesn't have to return a value at this stage because we don't know whether it will or not. We'll have void dev window. And you can guess what's coming next. Main loop. Again, I program in English. That's how I put in my commands, even when I'm writing them. So these are two functions. They are C++ functions in the C++ style. Also, if you were writing in C, they'd be exactly the same, sort of, except you don't really need the header file. All right, I'll save. Oh, we'll save all out. Right. How can we do this? I'm going to be starting up the main loop, and I'm going to say using an interrupt, because we've got an interrupt loop given to us by Qt, and I've forgotten how to spell interrupt. I'll keep it the same as I spelled it there then. It might be right, it might be wrong. I don't really care which. You can tell me if I'm wrong. I don't mind. So let's start. It's an actual action. So that's what we want that to do. And the main loop will be let's see. The main loop controls the flow of our program. That's English. Yep. Okay. So to set them up in Visual Studio, I just click on here and it says create definition. There we go. And it brings this up and it puts these things void. Yep, that's fine. Don't really want to place anything in there. Save. Okay, so you're going to do that every time I try and do this. Over here now. Make its mind up. Okay, we'll save anyway. Now, that's interesting. We now have a look in Dev window. It's put them underneath there. And test button clicked after. Let's do the same in the header. There you go. That means we can get rid of some of these lines now. Okay, we're okay on that side of things. Are we okay up here? Nope. Sure, save everything. That's looking good. So how can you do that? I mean, how do you create this interrupt? I mean, Qt's got all these interrupts from the operating system. How do we create our own? Well, this is going to be interesting. What we do is we move that. Remember the interrupt on the test button we made? We know how to make an interrupt. We didn't need that after all. I can move it to there with the other slots. I'll put space between. Don't belong together. Oh, I've forgotten all about the rule of 3 here for C++ viewers. If you're a C++ viewer, look up the rule of 3 under C++ class construction. I can't remember it and I don't use it. So there you go. Because I'm not a programmer. I'm a systems analyst. I don't know how to program. I just teach it. Right, so I've changed that slightly. Well, that now means it's a slot. Ooh, that's interesting. If I build that, is there an error? Any errors? Okay, the mock came through. That's where that slot is generated with QObject, and the slots are all generated using Qt's mock system. So it's done it for us. Okay. That is now waiting for an interrupt. But we can go one better. Interrupts can be timed. So every few milliseconds, we can generate an interrupt to run the main loop. Okay. I usually call it frame time, but it isn't in this case, is it? Okay. So what we will have is hash include, and I think it's just Q timer, Timer. Yeah. Okay. How do we use Q timer? I'm glad you asked. Not. I don't know. You look it up. Like we always do. Da 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 da. C D E F G H I J K L T. It's in this lot somewhere. Text. Huh. I always get stuck in text. That's better. Just hold my finger down now. Here we go. Q timer. Q timer event. It's this one I'm interested in. So it's Q timer. Header, hash include, Q timer. We've done that. Qt plus equals core. We've got that. inherits object, queue object. So it is an object, is it? Okay. Active single shot timer type interval remaining time. There you go. Simple enough. Now, do we make it as an address? Yes, we do. Because we can call on timeout and connect to a slot. So signals and slots. I don't usually use call on timeout. I just use connect usually. Interesting. So we have start int milliseconds, and stop timeout. Signals is the timeout. Ah, right. So, So what we need to do is make one of these timers. What can we have? Single shot. I don't want single shot. I want it to go on forever. Basically, we're going to do that. But it's these 3 lines here. So, yeah. Okay. Let's have a look at that. Now, I want do this in the C++ way, don't I? So, the first thing I'm going to do is take our example, place that as a private member of the class. Means I can place it here. The interrupt timer which connects to the main loop. And that will just be that, semicolon. Which means that we can now put in here, comma, timer, open brackets, pop you in there, and that's that instruction done. Okay. Connect the timer queue timeout this. I don't like the way they've done that. I'm not happy with the way they've done that. It's not clear what it's doing. It doesn't read right. You see, I would put in here signal. Make sure that is the signal. you remember back up here, timeout, brackets. I don't think you need the brackets, do you? Check. They haven't used them here, have they? No. Private signal. So it's a private signal to the timer. It can't be issued by anybody else. It has to be issued by at the timer that we've created. I don't like the name of our timer. Oh, blast, I just closed it. Never mind. Well, obviously, it's not an analog clock. Okay. Whatever we put in here, that means the Q timer is a child of this window. So we have to put it there as well. So we want the signal timeout. We get connect up, please. Is it not going to give it us? Yeah, here we go. It's the object sender, which is our timer. Constant chart signal, which we've called timeout. Can't we just put timeout? I thought there was a macro for that. Possibly is. After that, it wants const char star signal. Is that for the sender or who it belongs to? I think it is. Or is it where it's going to? Sender. Object receiver. Yeah, this. That's the object. The Q object is the dev window, so it's this. Comma. It needs to know who. Okay. And we've created a slot. And our slot is here. Now, do I have to put that in full or not? Okay. I don't want to start the timer. Until we get to here. Right, is this making sense now? Yes, it is. We've still got this. Okay. Lovely. So I think that is correct. I don't want a second. I want 10 milliseconds, please. That's 10 milliseconds. Main loop timer. That's its job. And we pass that address in there. That goes through to there. And we can start it there. So once we start it, it's going to wait 10 milliseconds, which is an eternity in computer terms. And then it's going to ask the program, which is running here, this application, to run whatever it's connected to, which is that. So connect the timer signal to this slot, this being dev window main loop is there. So what I normally do here, so that I know, just put that in. Oh, those are private as well, aren't they? Okay. I'll do. Tidy. 1, 2. That's right. Okay. And there you go. That's all we need to do. We are now using the main loop. This is going to, this might just flicker. So let's put something in our main loop and test it. Message from our main loop. There you go. I can use the same variable name because they are in different, what are called scopes. So that message dies at that bracket. That message dies at that bracket. So they will not conflict, but you will probably never see this this old message now. You shouldn't do anyway. Let's run. Anything? Nothing? Nothing. Why? Because we wrote a function, but we never used it. The other problem we have here is that when we enter the main loop, which is why I didn't call it, just wanted to make sure it compiled, we have to do something. Remember, it's an address of the main loop timer. It's not the actual value or function or whatever. Stop might be a good idea. And then when we've finished processing whatever we're going to do, we can start it again. There's no point in running our interrupt whilst we're processing whatever's in the main loop. Because we could interrupt ourselves if we do that, and that would be very confusing, wouldn't it? Lovely. Let's see if that runs. It does. Nothing shows. Push button still works. Okay. Right, let's use our new fandangled interrupt. So here in main, we set up a window. We show the window. After we've shown the window, then we can call our main loop. So start the main loop running. So it's going to be, why have we got W? Why can't we have window? Is that not allowed? And it's a dot because it's the actual window we're dealing with. And now we should have dev window, start main loop. Like that. That's all we have to do. Okay, Qt Cube connect. No such yep. Okay, I thought you were going to come up with that. It's even named dev window. Okay. So it was those brackets. I wonder why. I'm sure we have to put the brackets there. Oh, we did want the parentheses. Has this way of doing things been stopped yet? I don't like doing it that way. I'm going to have to, aren't I? I think this has been stopped. Okay. I don't like this way of using it. Hey ho. Call on timeout. You see, I prefer connect. This is where Qt sometimes confuses me in what it's trying to achieve. La 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 la. Where are we? Timer class. Oh, that's right, yeah. I remember. They're using an overload. Now they're changing the way they're doing it. I preferred the old way. Mind you, it was all these brackets that really picked people off, I think. Okay, let's get rid of that bracket. And I don't need to put the default part. There is actually another argument that you can put on the end here, but we don't need it because we're just going to use default, which is auto connect. Don't really need it. Oh, it's actually come up now. Oh. Well, let's see if it can work with that then. Okay. Mhm. Oh, I see. I think I see. We have to put the full. We have to put the name in front of it. Okay. Like that. Okay. Message from our main loop. We press the button though, but you can see that the spinny wheel has stopped because we're using interrupts. So we can use the mouse and keyboard as normal. Did you see it flick? There it goes, it just flickers. Because we're overwriting that one line. So what we can do if we want is... No, we can't. No, that's correct. Correct, and what I wanted to know. It overwrites whatever's in the window. There you go. We've now got a main loop. We can send control to anywhere we want within our program now. We can have an external main loop if you want. You don't have to have it here. But if you have an external main loop, you must have that in the class that is to receive or which holds the slot you want it to go to. It has to contain a queue object or be a queue object. Otherwise, it can't talk to it. That's the way Qt works. That's one of the things that queue object does. Very nice, isn't it? We've now got an interrupt system. So we know this works. got that working. Lovely. So, what do I want to do in the main loop? Not a lot. Start the timer to send the signal timeout in 10 milliseconds. Stop the timer so that we do not interrupt the execution of this code. And here, restart the timer to send signal timeout in 10 milliseconds. Doesn't have to be the same amount of time. You can use 5 milliseconds, you can use 20 milliseconds, you can use whatever you want. Or whatever makes sense for your program. 10 milliseconds is an awful long time to a processor that's running at like 3 gigahertz plus. That's 3,000. It's 3 million? 3 million instructions per second. Talking like 30,000 instructions or so that it can get through before it has to run this again. But it also means that we now have control over our own program. We have now taken control from Qt and its application and given it to us. So now we can do what the hell we like. And we now can set everything up. Main, yeah. Done. So I'm going to have to alter this, aren't I? Dev window, main program loop. Done. Find a way to represent an item of equipment within the computer's memory. Well, that's easy enough. It's just data. Or is it? Right. Where should we start? We've notated everything up. No, we haven't. Set up. No, it's not. Register a connection for the sender I'll just put sender, comma, signal, comma, receiver, comma, slot. So it's sender, signal, receiver, this object, and the slot, private slot. Okay, that makes sense. Ah, who was done first? Always do this reverse order. Always delete in reverse order to avoid dependency. Doesn't look right, does it? Dependency issues, errors. What this means is if you create something, then that something is used. Then if you delete the first thing, the second thing becomes an error because it's using the first thing that you just deleted. So we now have to, we did a new, it's main loop timer, delete. And that finishes that. That's all tidied up. Lovely. There we go. But you will have dependency issues if you don't do that. Even in this case when we don't, well, actually we would possibly do have a dependency issue. Doesn't look like it at first, but we could have if we just delete the UI. The timer could continue. Can't continue if it's deleted. So we'll delete it. So for every new, there is a delete. Use those two rules. For every new, you should delete, and for every delete, it should be in reverse of creation. Try and make all your creations up here so you can see which order they're in. And also, the compiler will give you helpful errors if the order is inconsistent with the dependencies. In other words, which one depends on which you shouldn't really have to worry about most of the time. He says, knowing that he's got it wrong in the past. All right, that's okay there. That's okay, that's okay. Done. Save. And this is tutorial 3, I guess. Tutorial 3. And that is dev window, main loop. Commit. Send. Pressing, successfully push. Need to pull. No. I won't. So there. Okay. Nothing else outstanding there. Right, so we can get on with the next bit. Let's talk about equipment in an RPG, which is what this is all about. We've spent 2 tutorials now just setting the scene, looking at the way I work, which is pretty straightforward, really. Obviously, I've done this kind of thing before, so it's nothing new to me. But what we need to do now is start thinking about what we're going to do here. Now remember, I've got this little thing, show all files, clicked on. If you haven't, it looks like this. Okay. So that's what it looks like. Completely different. Don't need that for a minute. Don't need that for a minute. Looks completely different. If I add another folder here, it will not add that folder to the hard drive or to whatever you are saving this out to in the future. In this case, it is a hard drive. I have a solid state drive on the operating system only. So I'm changing it over so that if I make a folder, it will appear on the hard drive. So this shows me exactly what I can see on the hard drive. And I'm going to make a folder. So, new. If I can find it on here. Add. There it is. New folder, it says there. Check it out. Take that off. Add. New filter. So if it says filter, you haven't clicked that button. I want a folder, please. And I'm going to call this source. S-O-U-R-C-E. In source, I'm going to add another folder called core, where all the core functions are going to go. What other functions do I need at this time? Let's have a look. I don't like that version of it. What the heck's this doing here? Go away. Oh, it's messed up, hasn't it? The last thing, didn't it? Yeah, I remember now. Where's users? Source. Repos. Mine. That one. Thank you. So what have we got? We have core, ECS, game rules, game world. What's the difference between a game world? That's got the dungeon, the monsters, the treasure item. Equipment is here under game rules. It hasn't been written yet. Okay. So I'll have game rules and equipment. Well, so source, add new folder. Game rules. And under game rules, add a new folder called equipment, where we're going to write some of the functionality. Anything else I should put in here? We haven't done skills. Okay. I think we've done this lot, have we? Looks like it. So what's treasure items doing? Models. Okay. And GUI I'm doing myself. Right, okay. It's fine. So core ECS. All right. Looking okay. Core. Okay. Let's see what we've got. All right. Do I have a list of items? I do, but it's in an awkward place. Is it probably not in here, is it? Actually, it could be. Damn big file. I do. All right. I'm not allowed to use GURPS. All right. That's fine. Ooh, don't do that. Let's pop it here for a second. Can't do that. They didn't like me. So we're not converting. Hmm. None is 0. Yeah, I agree with that. 2, 3, 4, 5, 7. What? Not going to work. 1, 2, 3. Sorry, no. 0, 1, 2, 2, 3, 4, 5, 5, 6. That could work. Huh? Hmm. Yeah. Don't like it, but it'll do me for now. 2, 2. If I get these numbers right, I'm a hero. If I get these numbers wrong, I'm an idiot. Well, I wonder which one I am. I know what the numbers should be. So that's higher AC gives us a better chance. Wait, no. No, that's Dungeons and Dragons, isn't it? Yeah. Okay. Yeah. Older versions of Rogue used the decreasing AC to represent better armor. Only on other people's versions of it when they were actually converting Rogue back into Dungeons and Dragons, which was quite interesting because that's where it came from in the first place. Or the ideas for it came from there. That's a D&D list of armor. Okay, so we can ignore top one. Or can we? No, because we have to start counting from 0. Alrighty. Right, one of the things that I always do, and I mean always do, is under the source, is to add a header file. New item. And it's a header file. And I call it common. Okay. So there will be a common here. I don't think I want to use this one. Try this one. All right, I'm going to go from here. Do I really want everything in here? No, not really. Ah, got you. I'll copy that lot over. Then I'll walk you through it. I wish you wouldn't put it on the first line. Bad idea. Older computers get very, very fussy about that kind of thing. Missed something off the end. Okay. I think I'm happy with that. That's got to... The reason I'm going to have to do this is because it's got things which are dependencies outside of what we are doing here. Just pop you in there. Go. Example. Component. Okay. That's okay. That's okay. And I have things in here which we can't use. Game state and shaders we're not using. So we're not using these structs. Okay. That's fine. With... That's an enum at the end. Why is it under structs? Didn't spot that before, did I? Entity's still valid. All the enums are still valid. Why is that enum there? No idea. Defines. Unused. Okay. Right. What's all this red stuff about? These are the preprocessor directives, and what the hash defines are just macros. So that I can put words into the program, and when it comes to compile it, it will substitute the numbers or the information I've given here. Okay. A Uint 32. Now this comes to our next part. We have to talk about numbers. Unfortunately, computers working on numbers, they have a limit, as can be seen here. Just trying to think if there's anything else. I mean, Visual Studio knows about all of these. It's just I don't want to keep including them. I'm not going to do a Qt common, am I? Decided against it. Okay. So we can have 4 million, 4.25 million numbers on a 32-bit machine. And because not everybody has a 64-bit machine, which basically gives you a lot more numbers, we'll stick to that. Sorry, 4 billion. Not million, 4 billion. So how many items are there going to be? How much equipment can we have in our game? Because each item will require a number. A unique number. A number not shared with any other item, so that we can identify it and know who it belongs to, or where it belongs, or is placed within the game. I think that's, in this case, a 3D world, but inside a game. And a lot of programs have a problem with this. Most notably is EVE Online. Every week, EVE Online has to go down for maintenance for an hour. And during that maintenance, they have to go through, delete, and reset all of the equipment that has been destroyed that week within the game. As in, no longer in use, destroyed, like dead ships, dead modules, all that kind of thing. Lots and lots of equipment gets destroyed every week. And that's to keep the size of their database down to what's in use. We don't want to do that, do we? We don't want to go down that route, do we? We don't want to use a database and have to go down for an hour on our server every week just so we can run a program to clean it all up. That's a little inefficient, I think. How many items are in World of Warcraft? How many players have how many items? It's a question I asked, I think it was in part 1. Let's just say a lot. Oh, we've got window title, window width, and window height now. Awesome. We could use those if you want. If you want to know how those defines are used. I think we should. So how is common.h used? It is placed as the first include for every header file. So let's introduce our common file to our header file. And it's the first thing you include into every header file. Hash include SOURCE tab common.h. We weren't on thingy. Common.h tab. There we go. And you must put it as the first item because included in there is all of the relevant information that we are going to store about our data, which is important. We've got some, haven't we? It's in main. Main. Okay. Just put it in there, can't we? So all header files. I always treat main as a header and a CPP file. So I always put it in here as well. That's the only other one. That's a header file. There aren't any more header files, are there? No, there aren't. That's it. Oh, there is one here, which we can't touch. This is not our. All changes made in this file will be lost when recompiling the UI file. So no, we don't touch that one. That's Qt's information file for our graphical user interface. Right, I said we had information in common. So we have a window title. We have window width and a window height. So where's our window? Here. I don't like the way they've done that either. Let's put an include. This is Qt that's done that, not me. So here we can put this. It's an arrow. Set title. What's it want? A Q string. Really? Will that work? I don't know. The window title here is Amber Rogue version 1 alpha. Save all. Let's try and build it first of all. Put a semicolon at the end because it's a command. Try and build it again. Amber Rogue version 1.0 alpha. There you go. Now, what we can also do, we can control all of this now from common, and we know where to find it. So window width and window height. So this set width. Is it window width? Is it set size? Ah, no, it's different for this one, isn't it? I don't think we can do it direct like that. It isn't, it's UI, isn't it? Setup UI, is it? That's the only function it's got. It's public. So now the UI will govern that. But that shows you how we can use a macro from common. So we have these things available to us that we can use. I'm not going to be using that width and height anyway because they're different. That's the map, rooms, storage, entities, scan codes. Let's have a look at these numbers now. Oh, question for you. If there are 4 5,294,967,295 items in the game, and somebody then buys another item from a vendor or a shop within the game, and a new item is created, what happens? What happens at 296? What happens if we break that rule? If we go past what the computer, a number bigger than the computer can handle. Well, it crashes in a very, very big way. Your program will stop running. Now, that's a problem. Oh, good, my export worked. Good. That's a very, very big problem. So let's go for max float on a 64-bit computer. Yeah, so what is it? Why can't you just give me the answer? Okay. So it can go from -2 to the 53 to 2 to the 53, which is an awfully big number. But we could still have more items than that. We have to use a unique identification number. And it has to be universal across the whole program. No other part of your program could use that number. So you can't use 1, for instance. You can't use the number 18,080, 40, 16, 12. You can't use 4 billion. You can't use 1,024. You can't use 28. We've already used these numbers. Can you see the problem? It has to be across the whole program. So as a number is used, the program needs to know. We can go one step further than that. Instead of using a universal unique identification number, why don't we just use a universal unique identification? I missed something off the end of that. Why do we have to use a number? We can't use words or letters by themselves. What about a mixture of letters and numbers? Okay. Let's research this a bit more. Now we've thought about it, we can research it. So C++ not equals plus plus UUID generator. How can I generate UUID in C++? Oh, we've got one on GitHub, have we? Yeah. Must be initialized by user. Yeah, okay. We do that anyway. So they've got a string of characters. Let's pull this out. Let's have a look at it. Where can we put this? All right, let's close. Close. Let's have a look at what they've done. It's important. Sorry. We've got common in, so we should be all right. Should accept whatever they've put. C standard lib. Oh, for God's sake. I've got standard lib.h here anyway. Same thing, isn't it? We can find out, won't we? I'll go from the namespace. Where's the if and defen? Oh, right. There we go. Is that correct? It is. They've just written it in a strange way. Okay, let's copy that out and have a good look at this, because this is where the fun starts. First of all, check for errors. Okay, haven't got any. Secondly, never do that. There's dotted lines down this left-hand side for a reason. So that you can see that they match. That is just bloody stupid doing it like that. The other thing is neatness. After opening a bracket, you can leave a blank line if you want. After closing, you can leave a blank line if you want. Just so it becomes more readable. So can you see what's happening here? Yes? No? Does it look too complicated? Do you think there's a simpler way of doing it? Well, it's generating a standard string. And it's not giving me an error. It should have done. There's a bracket missing. Because they had done that. So I missed it. The lines match up. Well, for starters, we can't run it from where I've put it. So we have a string of length 36 characters. We go through each of the characters. There's 36 blanks, or 32s. Blank is a 32, by the way. If I is not equal to 8, and I is not equal to 13, and I is not equal to 18, 14, 23, and the random number is less than 2 in hexadecimal, random number equals yikes in hexadecimal, plus standard random yikes in hexadecimal, or 0 if out of range. Interesting. I suppose that could go bigger than the largest random number you can given. Shift it over 4. Okay. It equals I equals 19, or RND blah 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 blah, or OX8 RND OXF. Yeah. Error. Okay. And it just returns the standard string. What that will do is just give you a mixture of numbers and letters. And you put in your hyphens in 8, 13, 18, 23. I wonder why 14's been placed in. Oh, in a 4. So that's obviously a marker. That's a checking marker to make sure it's come from the UUID. Is it usable? Yeah. Are we going to use it? Nope. Got the right idea. And we are going to have to use characters. But I'm not using a standard string. Okay. How can we do this in a way that makes more sense? Does that make sense to anybody here, by the way? It's how it's done. It's one of the ways it's done, should I say. There's billions of ways you can do it. We're going to do it differently. Let's get rid of this. See it. I don't want to be influenced by something that's probably very good. Not to me, it's not, because I don't it's very hard to understand. I can tell you what it's doing, but not why. Well, I can, because it effectively is saying that you can't have the same thing ever again. What you really want to do is keep track of your UUID. This presents problems. What happens if something is removed from the game? What happens if an item gets removed from the game? How can you replace that UUID into active service so you don't run out of them, basically? Because no matter what system you use, eventually you will run out of identifications. Even that system that was presented there. I'm going to use it. So, how are we going to do this? Find a way to represent an item within the computer's memory. So we've decided we have to use a universal, unique ID, not a number, but a universal unique identity or ID. Now we can make that whatever you want. But it doesn't matter what we do, they're going to run out. Or you are going to have to clean your system on a weekly basis like EVE Online does. You might have noticed I have that. Unused. As -1. I have a third option in my logic structures for programming. I have an unused value as well as your true and your false. I use a rule of 3 like Mother Nature does. So, how can we start building something like this? What do we need to think about? So how do we represent this ID? That's easy enough. We use a character string. Okay. I'm just wondering how many problems this is going to cause. Absolutely millions of problems. Or billions of problems, maybe. And how do we reuse deleted IDs? So how do we keep a track of deleted IDs? Because you have to. And you have to reuse them. So that's something we can do. But here's the problem. If we use a character string, how do we store it? We can't. Because you would need to use a number to store it with. Do you see the paradox? You have to store it in a location in memory. Someplace. It's an item of data. And a location in memory is a number. Hold on a minute. So why don't we just use a location in memory? The actual location in memory. That has to be unique, doesn't it? Ah, but what about external? Ooh. Databases. Oh. Didn't I say we weren't going to be using a database? Did we use a character string? How problematic is all of this? Let's dig a little bit further. I generated whatever that says UUIDs using this methodology at 6K. It lost its uniqueness and started producing duplicates. Yes, it will, because you're using a randomizer. You need to know how random numbers are generated in a computer to find out that that is probably as good as you're going to get it using that system, matey. Okay. And here's another one. Yeah. Isn't unique enough. Shouldn't be using random. You want something random. Okay. Hmm. Hash include uuid.hh. Yeah, okay. It's not going to work with random number, is the answer. Not on a computer, it won't. Anything? Search. Okay. The UUID class stores a universally unique identifier. So it has a string format, a variant, and a version. Okay. It has a GUID variant, QByte, array variant, and a QString variant, which is okay. Okay. Operator equals. Should it be copyable? No, it shouldn't really. Bit dangerous. Is null, right? 2CFNS, 2RFC4122, 2string with braces. Okay, fine. Variant version. Right, okay. Create, obviously. From string. Oh, you can put using inputs, right? Okay. So they're using hash maps, which are awkward for me to describe to you right now. Right. Using universally unique identifiers is a standard way to uniquely identify entities in a distributed computing environment. A UUID is a 16-byte, 128-bit number generated by some algorithm that is meant to guarantee that the UUID will be unique in this distributed computing environment where it is used. The acronym GUID is often used instead, globally unique identifiers, but it refers to the same thing. A GUID is actually a variant, yes, thank you. Not saying that and correcting yourself. Of the UUID is a subsection. A universal unique is across the whole system. A GUID is global, which means to possibly one program. Whereas, for say Windows is a few thousand programs and would need a UUID system. And within each program, there could be a GUID system, a subsection of it. Multiple variants are in use. Each UUID contains a bit field that specifies which type variant of UUID it is, or variant, to discover which type of UUID an instance of QUID contains. It extracts the three most significant bits of the byte 8 of the 16 bits. Yeah, that's where they get put in the 4. Yeah. Byte 8. Yeah, if you create instances of it using the constructor that accepts all the numeric values as parameters, Thank you, Muppet. Use the following table to set the 3 most significant bits of parameter. So, network computing system, a DCE distributed computing environment, Microsoft Uuid, and reserved for future expansion. We would have to use network computing system. Which is variant 0. UID contains a version field. You can call version to discover which version your QUID contains. Accepts all the numeric values as parameters. Use the following table to set the foremost time. Version is time. I think time and date is probably the best idea. Embedded POSIX, MD5, random, SHA-1. Random doesn't work. Don't use it. That's dangerous. If you want me to go into the randomness of computers and give you a full lecture on that, I will title it Random Numbers. There is no such thing. There is no random number generator on a computer. There's only one that I know of that exists. Actually, there's 2 because it's been duplicated, but that's different. Can't talk about it, part of my job. Right. But they are not computers. They are random number generators. Big difference. Contains a version field in its 4 most significant bits. Okay. Very complicated. With braces, without braces. ID 128, only the hex digits. Without braces or dashes. Note that QUID cannot pass this back again as input, right? So we need to use with braces or without. And that's what one looks like there. You've seen them before. Windows asks you to type in your GUID for the Windows disk that you use. Variant is unknown. Backward compatibility. Okay, so we're using distributed computing environment. We're using DCE. Now here's the problem. If I use QUID, how am I going to use that within a program without using Qt? Using timestamp, clock sequence, and MAC network card address, if available, for the node section. That's clever. I like that one. So I can't use Qt. It comes straight up with the Qt one. That's interesting. I didn't put Qt in there, did I? C++. No. Yeah, here we go. Let's research these. Oh, yeah, time-based in Qt. Straight back to them. A timestamp, a clock ID, a node ID. Timestamp is a 60-bit value. And that's in nanoseconds since 15th of October, 1582. Local time can be used. Care has to be taken that the clock ID has to be incremented when the clock is set backwards in this case. Okay, yeah. For daylight saving time. Generally, a programmer does not get the current time in nanosecond intervals. Millisecond precision since the 1st January 1970, yeah. To come from milliseconds to nanosecond precision, multiply the time returned from the system by that, add an offset of that. Okay. Right, so can use a clock ID. The initial value should be a random one. If a new timestamp appears to be older than the previous timestamp used, for instance, after a clock skew error or after a reboot where the clock was resynchronized, the clock ID should be incremented by 1. Yeah. A clock ID of a 14-bit value will always overflow. But it's the best idea we've got so far. But I'll show you a trick in a second. Don't you worry. Because I'm going to ask a question that's going to blow your mind, and all the complexities I'm showing you here. This is for the advanced guys as well as you people who are learning from scratch. I'm showing you what you're expected to know. Introducing sleep tabs. Okay. Okay, the node ID. MAC address. Ethernet address. 802 address. Should be unique. Yes, they are, usually. But not always. Though some no-name manufacturers are known to reuse these addresses. The address can be from a network card of the machine where the UUID is generated, or of another machine. Network card. This means we can have networked UUIDs. That's important to know. But this node can be used in a different way. Yeah, that's been done before. I'm not saying that out loud. Retrieve from the IP configs. Yes, we know about that. It looks like a MAC address. Yeah. Hexadecimal value. So you're only taking that part of the timestamp. Then you're reversing the next two parts. And you've got a check there. The one before the most significant digits of the timestamp indicates the UUID version. So what I've highlighted there is your version 1. For timestamp-based UUIDs, this is 1. The remaining parts of the UUID are the clock ID and the node. So the clock ID is 9669. And then you've got 0800 200C 9A66, yeah. Why 9669? Okay, the remaining, yeah. The clock ID was 1669 and is put in the following UUID as 9669. The first digit isn't a 1 because also the most significant bit is set as mandated by the variant. Okay. Got ya. Makes sense now. The node ID was blah, blah, blah. ID. If the node ID were something generated, I can't even read that because it doesn't read. ID was a generated one. The first octet or 8 would have to be 09 instead of 08. Okay. So what they're talking about is this hardware thingy. It has to be an 09 if you generate it, an 08 if it's taken from the system. The correct way to construct these identifiers is described in RFC 4122. The contents of this document is my interpretation of that document. Okay. So somebody's actually thought about this. Okay, how is a time-based UUID made? That's what we're just looking at. Blah, blah, blah. All right, so this is just information. Okay, disclaimer. All right, that's fine. Don't mind you having disclaimers. Quite used to them. Okay. Okay, this is a Java runtime, is it? Alright, if I press get, it'll do one, I guess. Yeah, it's just popping them up here. Hmm. Okay. It's not giving us information on... I see. Let's see what this is now. Okay. Don't use random, please. Alright, this is an online UUID maker. It's just an example. Okay. Hmm. Oh god, it's in the Boost library. We don't have it in the standard library. Okay. Alright. Alright, so you've made it into a class. And I think we've just gone round in a big circle. I'm not going down that now. Ba-dum-ba-dum-ba. Here's your include. Is it just an include file? Oh, they've done it right. Hmm. Linux, Unix, yeah. People doing the beginning of things. La 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 la. Yeah. Oh god. Yeah, they've done it as a header file. So we could use something like this. Is the answer. And they've given it here all that garbage I've just been through. Okay, so you've got a UUID variant. And it's an E number. 0, 1, 2, 3. Okay. This is just repeating what I was reading in the QT manual. There's your class. Can we write this in English? I mean, I don't mind using it, but I'd have to strap it off somewhere. I have to namespace it because it's not my work. Generators. Okay, we are at... That's not bad. They've done it in just short of 1,000 lines with good explanations in there. That's worth looking at. Do I use theirs or do I do my own? All I'm doing is repeating what's been done 1,000 times. Why use this UUID system? Because if something dies, you just delete it. You don't reuse an ID. Because it's time-based. The time will never go backwards. Or need to be repeated, should I say. There is one slight problem. I do want to use the time-based one. They haven't gone as far as I would have gone. They've pulled up short. Right, we need to think about this. What does this do here? Favorites. Would it just click on it? Doesn't give me any information. Add current tab to favorites. Oh, thank you. Thank you, that'll do. Alright. I think I might be coming back to this. I'm just wondering why I would need it so complex. I was going to go for something a lot simpler than that. I might be right on my own. Now I'm going to throw spanner in the works. We can identify items by an identifier. There's one there. Armor. Yeah, what 0, 1, 2, 3, 4, 5, 6, 7, 8 types of armor. That's all we're going to have. If you make it completely random, you see, you've got to put that as in the first component you add. So what have I just discovered? For a pure time-based UUID, we would have item category in the description component. Or we can use the category as part of the UUID. Now, why can't I do the second one? A simple answer. But it's a complicated question. Because you can. What I could do is I could have a category letter, say, or string of letters like armor. Like armor, and then you'd have hyphen, time, stamp, and we would then have a problem. Because if two computers running the same game or client create an item at the same time, you'd have a duplication. And that's why they use the MAC address of the computer that creates it to make sure that timestamps can be duplicated across networks. Things can be done at the same time. So they don't normally do it this way round. What they would do is just have a pure UUID and then a description component for that UUID. You can still only hold within the computer a maximum number of items. You can never go beyond that. But on a single computer, you shouldn't be going beyond that. This is where the database came in. And what you would do then is you would have a database, you'd register your item as it's created into the main database. And as that's emptied out, then deleted, whatever, they would have to use some kind of stacking system to do that. I'm not going into that right now. I think we've got nearly the answer, but it's probably brought up a lot more questions from you lot. How on earth can we do this easily? The answer is to use what's already been done. This header file. Name, constants, yeah, library, yeah, using the library. All right. Creating a new. All you do is you put the header file into here. That's all you have to do. Put it into core. Creating a new UUID with a default random generator. No, thank you. I don't think random number based is a good idea. Oh, but it isn't all the same. From string, okay, dot val, yeah. And then you would have an ID. Yeah. Name base SHA-1, yeah, I understand that. Ooh, swapping. Yes. Has he not done the networked one then? Oh no. Why do we need to build it? I might do that. But not on this machine. I think I don't mind doing that on a Linux-based machine. Work a damn sight better. DNS URL OID X500. Okay. ISO. All right. All right. System generator. Yeah. I'm interested a little bit. What's this doing? Boost. Is this legal? What's boost under? Is it MIT or is it GPL? C plus plus boost. License, Boost software license. Free open source license known as a Boost software license. It is a permissive license in the style of BSD license, MIT, but without requiring attribution or redistribution in binary form. Okay, fine then. Free software license. Yeah. Okay, that's fine then. Clear on that. Alright, this is just the Boost library bits and pieces that they pulled out, isn't it? And there's lots of it. This is bad. Look at this. Internal catch message. This is a program within itself. Do we really need this much? Okay. 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 Alright, so that is possibly the closest we've got. So we've researched that now thoroughly. I hope. As I cannot use the Qt version. Right, so we now know that we're going to need to use a UUID, and we are quite comfortable with that idea, I hope. We could try and make our own, but we are going to have to go for the top one. I can't do that. That would just be breaking all the rules, and that would not be very good for anybody. This means we can use an ECS. And that's an entity component so it's entity slash component and it's slash system plural. All right, so ECS. Okay, this is good now. Entity component system. Okay, no. Don't do that. That's going to confuse everybody. Okay, Qt3D. Okay, can't do that. Qt. Qt Quick 3D. What happened to Qt 3D? Ooh. Can anybody tell me? Look under index. What time are we on? Okay, we're okay. No, you're a bit early, Muppet. It'd come at the beginning, wouldn't it, for 3D? I would guess. Hmm? Qt OpenGL? Ah. What? Don't understand. What's happened here? Ba-da-ba-dum. That's all Qt quick. What happened to Qt 3D? Have they stopped doing it? Interesting. Hmm. This is all Qt quick. Oh. C++, please? No? No? I don't understand. Hmm. I wonder. Things go missing from the manual. That's not like cute. 3D. This is all Qt quick. Oh no! No! That's not fair. Something has gone astray, it would seem. Have they removed all the files? Hmm. Okay. Okay. Oh wow. Something's not right here. It doesn't matter. Right, so what What? Where? Why? Yeah, entity component system. I just wanted to show you a very, very good thing that Qt did on entity component systems. But hey ho, documentation not available. It might just be under ECS. No. Copy under entity. Fantastic paper they wrote. No. Now coming up in here. Keeps going off into XML. Which we're not doing. Right. What is an ECS? I'll run through the basics by the sounds of it. That's a shame. An entity is an item, a thing. It can be anything really. It could be a 3D object. It could be part of a database. It could be anything. It could be a knife or a fork on your table. It could be a cup of coffee, which I haven't had. It could be anything, but it isn't. It's a number. That's all it is. A component, an entity, it's a bit like the menu. It's like a menu heading. The components are the components in the menu, and then the systems act upon the components. Very easy system to construct, very simple and very powerful. I'm using it currently in my 3D game that I'm making on the side. So I can't see why we can't use it here. A lot of people get this mixed up where they make entities into... an entity is just a number. A component is a set of data, and a system acts upon that data. And you can have any number of systems acting upon any number of components, and any component can be used by any number of systems. And it's just a handy way of, well, an easy way of making the computer work. So I think we'll have ECS. Yeah, it's just ECS. So under source, we'll add a new folder, and we will call it Shift ECS. And under ECS, I think we split it down. Components and systems. So add new folder. Component. And we'll have another one. Add a new folder. Systems. There we go. And the only thing we need, well, there's two things we need in here. We need the entity, obviously, and we also need a header file. Let's see what I called the header file. Fair enough. So those are your 4 files, basically. All right. So we will need add new item, header file. We will call this ECS underscore component. All that's going to do is be a header file, which just gives all the header files for the components that we make. That goes there. It should be empty. I'm going to leave it on the top line. I don't care now. I've now got to make a header for all of these. That's fine. We'll talk about that next time. New item. All I'm doing is I'm putting together the basis of a computer program. I already know what the computer program looks like, so I'm lucky. Systems, ECS systems.h. We don't need to look at these for now. And the ones that we do want to look at are new item, entity.h, and new item, class. No, CPP file. Entity.cpp. There we go. Those are the files that we will need for our ECS system. To start with, the only thing we're really going to need is the entity itself. Now, the entity, as I said, is just a number given by the system to each entity as it's created. And it goes something like this. Let's have a look. Did I take that top line or not? I don't know. Cares. Right. Okay, there we go. And this one starts off as hash include entity.h. There we go. There we are. So these are the things that you will want to do with your entity. You will wish to initialize the entity system itself. Entities, the entity update. I'm not sure really how to describe that right now. I don't think I've really decided yet. To create, to destroy, adding to rendering because I was doing it 3D, and remove from rendering. We're not doing render. Take those two. So entity create and entity destroy, entity update, entity initialize. Why do I need an update? All right, it just returns that. So we don't need an update. So what we will have is don't need it. We just need initialize, create, and destroy. Not sure. Not sure. For now, yeah. I never expanded this, did I? That's entities to render against. No, we don't need it. Okay. So we've got three functions for an entity. To start off with, we have initialize, create, and destroy. So let's make those files. I'm just going to copy them and I'll explain each one as we go. I think it's easy enough not to put any comments here. I mean, what they mean. Did I put a header file on it? I didn't. Never mind. Right, let's have a look at initialize first of all. This requires us to have an entity list. So what it does is it goes through the entity list and initializes every single entity on the system to be unused. Yeah, that's okay. So we need an entity list. And that is easily, let's have a look. We'll have that one. What was the other one? Entities. Don't need to deal with. All right, I'll have you. There we go. So, all this does is loop through all possible entities. Now, this is where it becomes fun. Possible entities. And set to unused. After what I've just been talking about, do we still need to do that? Well, no. We wouldn't, would we? But this is why I need to put this in at the moment. Entity list. Static means it can only be used within this file. That's all that means. It's part of C or C and C++. It's a keyword. Just means, hey, can only be, it's here, and you can't use it anywhere else. All right. Nothing else outside of this file is allowed to access it, which is why in the initial one I had entity update, the other static one, so we could access it. Okay, that's all that means. So it's just a block of memory to store our data. Memory for storage of data. Got to stop making it personal, make it more professional. Data. Mark as static, so it can't be accessed by the rest of the program. It's a bit like marking something as private in a class. This kind of thing was done before classes were invented. Put it that way. So it's my preferred way of doing it as well, because it means I know where the data is. It's here, and it stays here, and it doesn't move anywhere else. Okay. So all we do is we go through all the possible entities and set them to being unused. That's how we initialize it. Simple. So back in main, we can now do that. Oh, wait a minute. Let me just put empty thingies in. Create. Return entity. Yeah, okay, that's fine. That's what you want to. It's just written it for me, so fine. Okay. And that's okay. Because I've got common in, and it knows what an entity is. Let's have a look at what an entity is. I wrote that. So I know what an entity is. And if you remember, I said it's in common. Oops. Where I put all my stuff. If we could just look down here, we'd have an entity. Structs. There we go, entity. An entity, believe it or not, is just like I said, it's a number. It's an integer. An entity ID. A number from 0 to 4000. Or in this case, I think I set max entities up here. Yeah, max entities. We can have 1024. So we aren't going to have that many. Yeah, that's fine. It's not a lot, but that can be changed at any time. That's all we need at this point in time. Unreferenced formal parameter. Where? Oh, right. It's just unreferenced. Is that it? There's no errors. Right, that's okay. Just tell me I didn't do anything with entity. Everything's working nicely. As such. So I would advise that you do one of these common.h's, and every time you make a file, you put source common.h in. Why? Because then you've got all your library includes already sorted out for time, the booleans, strings. I use a C standard library. I don't use very much from C++. I only use vectors and strings. At the moment we're using Qt, so we can use QString as well. Probably use QString at the moment. I need to, no doubt. Right, yeah, so it's giving me the screen squiggly. We haven't done anything with it. So let's create an entity. Easy to do. Entity, create. You alright there, Muppet? Making funny noises. Oh. Lovely. So, search through the search through the entity list for the first unused index. So for index, I'll put it in English, so I'll use the same words. Entity list index. We're looking for the entity ID, which was set to unused for them all. So the first time we create an entity, it will be entity 0 will be unused. So entity.id equals index. Breaks out the for loop, drops in here, equals the entity. And that's it. That is so not self-explanatory. Entity list. Let's do this properly. Find the first unused index. So in other words, if an index is equal to unused, which it was set them all to, so if it's the first time through it's a 0, what we do is we make the entity ID equal to the index 0. I'm just wondering why I've put it there. All right. All right, this is an entity list of entities. So type entities. Yeah, got you. That goes from 0 to max entities. So we use that for the index. That would be a 0. That would equal the entity that we've asked for, that we're creating, and then we just return it. Simple. So we create an entity with the index number as we have found an unused, and yep, that's okay. Break out of the for loop as we have found an unused slot, an unused index. Yep, that's okay. Store the newly created entity to the list. There we go. And you can return the entity in case they need to know it. It's optional whether you want to know what the entity is called or not. Some people do, some people don't. They just might want to create an entity. But they usually want to equal, they want to know what it is. It's a number stored as entity.entity_id. An int, and that's it. All it is. It's nothing complicated at all. This is the simplest function that you can do, and it's wrong. Why is it wrong? Well, what happens if it doesn't find one? If it doesn't find an entity, it returns an entity. Which doesn't have an entity ID. Isn't that interesting? In fact, that will generate an error and crash your program. Isn't that interesting? Also, 1024 cannot be used. Ah, good. Less than. Less than. Good, yeah. I did remember to do that. That's good news. Sorry, I wrote this rubbish. That's the simplest you can do it. And that's a function which will assign a number on the grounds that it is an unused number in a list. And if you ask it to assign the 1024th item, it will crash your program. And you deserve it to crash as far as I'm concerned. Because you couldn't be bothered going into common.h and changing the ruddy number for max entities. Because that's all you have to do. Which is why there is no check for an error. It is not up to you as a programmer to check if there's an error. It's up to the person who designs, who designates the specification for the program. They will decide that number there. They have to. Because you're going to state that you have to the person, you have to specify this number. If you specify a number that is too small, the program will crash. Or the program won't work, I think is the technical way of putting it. If you misuse a program outside of specification, it won't work. So at the moment, the specification is 1024 entities. If I ask for more, then I deserve what I get, which will be gobbledygook. I do not advise anybody who wants to become a programmer as a profession or run a business for programming to let the user get away with not specifying things. As soon as you know what needs to be specified, make the user specify. And if they don't know, ask them why they don't know. They say it's unlimited. Say, well, your computer's memory isn't. Because that's what we've just been talking about, unlimited numbers, UUIDs. And that comes into this now. Because now we have an entity Oh, we better initialize our entities, hadn't we? Yeah, I think that might be a good idea. The entities, by the way, are not a class. This is not a class. Just a bunch of... It's 3 functions. That's all. Just 3 functions. Nothing else. It's not a class. It's not inside a class. There's 3 functions you can call from anywhere in your program, as long as you include entity.h. So, where is the start of our program? In main. Okay, let's pop it here then. Actually, no, I've got libraries, haven't I? And this is... from the source files. And we'll have hash include. This could be a bad way of doing it. Don't care. For now. Why is hash include not allowed? Source. ECS. And we will have entity.h. Like that. We don't need to make an entity. All we have to do is initialize it. So what I'm going to do here, initialize the systems used by program. So I want entity, and I always do it this is why I have a naming convention. So it's entity, initialize. Done. That's it. We now have entities, and we can use them anywhere in our program. All we have to do is include entity.h and put in entity create, and we can create an entity anywhere we want. Isn't that ace? Very, very simple, very, very easy. Nothing problematic there. Have I still got missing function? Yes, I have. Okay. Just do a check build. Shouldn't have any errors this time. Oh, entity ID unreferenced formal parameter. Entity.cpp 4425. There. It's not being referenced in here. That's what it's trying to say. So how do we destroy an entity? This is comical. You do the reverse of create. You do that. You take the entity list for the entity ID and set it to unused, just as if you were initializing it. And of course, once you've done that, next time you create an entity, it will pick it up as unused and reuse the ID. Simple and beautiful. Well, if it's that simple, why do we need all this rubbish about UUIDs? Do we? Yes. Yes, we do. Because an entity would be leather. So we're going to make leather as an entity in the category of armor. And it's going to have a statistic of 1. Because I just wrote those numbers out because that's my statistics. So stat. Are you getting the idea now? All of a sudden, a system is starting to spring its little minding head. So we're going to need a UUID. Name a category and a UUID. What we need. So category, name, stat, common. We need a component. I'll put an example in. So let's make a component now. Let's go really overboard here. But now you know why we're doing this. Type def. Enum. No, it's not. It's a struct. Remember, a struct is just a class, but everything's public. It can do everything a class can do. But we're not going to do much with it. All we're going to do is struct. We're not even going to name it. Well, we are, but we're going to name it at the end. Component. Item. Well, it's a header. I don't want to say header though, do I? Because that's programmatical, not English. So item script. How about that? So we will need a UUID, which is going to be a class. Well, it's going to be a something. And that's just going to be UUID. Doesn't have a value at this point. We would need... Oh, the first thing you should always have is your entity ID. Int. Entity. You must have that for this system to work. ID. It has to hold that value. I done? You must have that. We don't know what a UUID is, so just note that out for a second. Then it was category, name, and stat. No. It's just category. So category and name. That's a char star. Name, title. Alrighty. I think we might have to have a bool stats. Or bool type. No, that's in category. That's its type. I haven't decided what that is. Okay. We will need a title. That's definite. Stats. It doesn't say here that it's... That depends on the category, doesn't it? Yeah. Okay. For my purposes, you should always have an enumeration of your components within a system. So we'll have to put this as the example, shan't we? Put it here. What we'll do is we'll just take that out a minute. That's part of my system, not the generic system. All right. Because obviously I need position, 3D text, monster AI, and combat. So. For my game. So we'll start a new list. Type def for us. You don't need the other one. You don't need the bits in green, by the way. That's just for my reference. This will be component. This list will start off with the component comp item description. And that equals 0. And I've lost an E. There. Thank you. Right, so that sets our first component up. Excellent. Each component has to have its own file. to manage it. Because each component is different. Which is why I had a folder made for components. So now we've written that, we can now write our first component. We can't put too much information in it because we don't know what the information is relating to. But that's our first component structure. The files that you have to write for a component are very, very simple. How was I wording them, please? That's fine then. New item, under components, header file. Oops, goofed. Remove, delete, add new item, file, header file. Okay. And it's a component. Don't know where to find it. Underscore item underscore description. Don't hold back on the words, you know, or this, you know, what you type in. Don't start putting abbreviations in. Get out of that habit quick. Okay, there we go. There's our first component made. Isn't that good? Lovely. Does a lot. New item. And it's a CPP file this time. And it's component. Did put a header file on that one, didn't I? A component underscore item underscore description.cpp. Think down one hash include space component description. Thank you. So return, save. There's our files. The only other thing you must do, and you must do it, is under components.h. Hash include. And it will be components description. There we go. You must add it to that file because that's the file we'll be including, not each individual component. That would just be asking a little bit too much. So we've now got our first component. And so we're on now building our first component. I didn't want to do that first and then stop and try and explain what a UUID was, which is why I did UUIDs first. Okay. I think we're settled with that now. So we've now introduced the idea of an ECS. We know that an entity is just a number. We can tell that because that's exactly what it is. It says it here when we create it. It's just a number. Entity ID equals the data for an entity is an entity ID, and it equals a number, an integer, an int. And you can double check that in Common by looking at the entity, and all it is an integer, entity ID. which is why I have a common file. Now for the components, we have added a component. We're going to make a list of components as an enum, which I haven't explained. An enum is an automatic enumeration, or in other words, number, starting at 0. And for each item that we list down here, it will increment it, that item to equal the next number. So the next item we add in this list will equal 1. This enables us to efficiently access and use our components, or find out which component a system would like to use. So when we design a system, we will say the system requires component such and such. Please can I have that data? And we'll get the data for it using the identity number or the entity. Now there might be 10 bazillion item. Let's just take one item. Okay, main, one item. Leather. Okay, somebody's gone to the local shop in your game and they've just bought 5,000 leather jerkins to sell to the players around the game. All right? But we can only have 1,024. Well, there's only one entity. But there can be many copies of that entity. The entity is set in stone. Each of the individual copies, well, they can do their own thing. They can exist in their own space. But the actual item will be a UUID. The item will just describe it. I can add a component then later on, say for a model. And it'll be the same model for every single piece of leather, or leather jerkin, or whatever you want, a jacket, or whatever you want to call it. In the world, that entity ID for that jacket will always have that model. You could have various different models, but they would each need to have a separate entity. Do you understand what I'm trying to say? I hope you do. If you don't, whisper me on Twitch, or come and type in chat, I don't mind. Or make a note, or just put a note beneath the thing, the video on YouTube, if you ever go over there to watch it. But otherwise, I think that's roughly about it. How long have we been going for now? 3.5 hours without a cup of coffee? We haven't got to the systems yet, have we? As you might notice, the systems don't go in common. There's a few systems there. There's one for moving entities, and there's one here for text 3D. So there's 2 systems already here. Both use different components. Both have models. The model isn't here. You'll find the model there. But the system can use whatever information they want out of any of the components for that entity. So it's an interesting system, and it builds up bit by bit quite nicely. So I'm happy with that. And that means we're up to there. We should be able to build and run without error. somebody's going to say something soon. I know this is going to come up as a question. But you put all of that data into memory. Yeah, I did, didn't I? Yeah, it still works. But won't you have a memory leak? Well, what do you think? The answer is no. We don't have a memory leak. One, I checked it to make sure that Microsoft did it right. All the data is held here in this file, and it's in global scope. When the program hits the last main bracket, the main function, that last bracket there, everything in here is wiped clean. But that's in global, that's outside the brackets. That's why I always have a space at the bottom of my files. See? Always have a space. Always have a space. You ever wondered? Always have a space. Always leave a space at the end of your file. Because that's the line upon which all the globals are destroyed, and all the memory that the globals are using are freed up by the operating system. It is the operating system's responsibility to do that. If you do not leave a line at the end of the file, let's just say that certain versions of Windows will cock up and give you a memory leak. I know this from experience, which is why I checked it on Windows 10 to make sure that I didn't have a memory leak if I didn't put it there. I always do. And I never trust them because they keep updating it. So I never know whether their system behind the scenes is up to date with reclaiming resources assigned to a program. I leave that line for program close. It's a marker that is inserted by the compiler that the operating system sees upon closing the program closing and gets its resources back. Any resources that have been used by the program are then reclaimed by the operating system. So there is a marker. I just make sure there's a line in case I want to put it into one of the stupid files they make. If you ever, look at all the files they make. It's ridiculous. Look at it. All these files are made. And there's more. Why just leave them a line in case they want to put that information into one of these files? Well, I'm just polite. Tons of files are created when compiling. So our program works. We have a way forwards. We understand now the need for a UUID because things will get a bit yikesy if we don't. We know the basics of what an ECS is. I've glossed over it a little bit because we'll get very familiar with ECS because we'll be working with it quite a bit. And we will be designing systems for this. Our first system will be to display all the items. But first of all, we need to be able to create all of these entities. Decide where we're going to put them in our entity file. Did I do that or not? I might have done. All the model numbers and everything. I just create the entity there. Entity item equals entity create. That looks familiar. Yeah. Okay. I'll have to refer back to this original. Reward level and location, okay. Just make one. Location. I just add it to the renderer, okay. Right, nothing going on there. Food, gold. So I've got the item categories here. And I shouldn't have. They should be in common. So we've just done category armor. Okay, we'll come back to that. Right, that is it for me today. I'm going to go and have a look after my poorly cat, who is very poorly. So we have been introduced. This is 3, isn't it? Tutorial 3. Introducing UUID and ECS first steps. Okay. I think that's the best way of putting it. Because we are going to have to take this a step at a time. I am going to have to work out how we're going to manage the UUID. Do we make our own? We should. We really should. Not to worry. It's got the components, ECS, components, yeah. All the new files, common, yeah. Okay, I'm happy. Submit. And push. Wait for Microsoft to do its magic. Visual Studio is up to date. And we now have the beginnings of an item system. We haven't made an item yet, but building our first component, no. Right, let's just check, just double check. We've found a way to represent an item of equipment within the computer's memory. So that's done. UUID. How do we represent this ID? Using a character string, correct. How do we reuse deleted IDs? No need to. As we can use time stamps, which is type 1. Remove the page. Variant. That's better. Okay. Yeah. Pure time-based UUID, we would have item category in the description component. And did we make a description component? We did. And we decided we only needed I thought we did. Huh? What's just happened? Where's everything gone? Oh dear. Bless this thing. Where's it put it? Alright. Oh, we haven't done the component bit. Oh, we've only done the entity bit. Okay, we haven't done the component. My bad. Glad I looked at that. Okay. No. Okay. Description. We can. Okay. That's done. Talked about that. Building our first component, which will be component item description. Item. This is for me, actually, more than anything else, because I forget everything. And here I'm sitting talking about it and I just forget everything. So yeah, we're going to have to build that. I think I've given the game away a little bit by accidentally showing what we're going to do. Anyway, in the meantime, it's Saturday. Go and enjoy yourselves. Have a good night out. Have fun. That's all I can say. I'm going to go and feed the cats, or the cats are going to eat me. And I think I'm then going to try and sort myself some food out. Anybody who's popped by, thank you. It's appreciated. People want to pop in. And we're going to start by talking about something slightly different. Well, we're going to talk about a bit about programming in the next one as well. Yeah, because we haven't done it. Right. Lovely. Not a problem. Miss something. We can do that. Yeah, that's looking good. There's enough notes there to kill a book. More notes, less programming. That's what the doctor orders. Okay. Take care. Stay safe out there in these weird times and have fun. What did I do with the button? In this one? Ah, it's in here. I found out.